Here's number 35 from tonight's homework. To start, I'm going to use the power of a quotient property and distribute, but not distribute, the 3 to everything inside of the parentheses. So 3 over 8m to the 5th remains the same, and it's being multiplied by m to the 12th. Power to a power, you multiply. 4 times 3 is 12, over n to the second raised to the third power is n to the 6th. Now I'm going to multiply straight across, just like I would with any type of fraction multiplication, and I get 3m to the 12th over 8m to the 5th, n to the 6th. So I look at my new fraction to see if there's any like bases I can simplify. You always want to look at the numbers to see if there's anything that can be simplified, if there's any common factor. So if I look at 3 and 8, there's no common factor, so those two numbers are going to stay put. They're going to stay as they are. Nothing's going to be simplified. I then look at my like bases of m, and anytime I divide like bases, I subtract my exponents. So 12 minus 5 is going to give me 7. So my final answer is 3m to the 7th over 8n to the 6th, because n to the 6th was the only base of n that I had in my fraction, so that's not going to be changed at all. And this is my final simplified answer. That's a 7 right there. All right, here's number 45 from tonight's homework. 45 is without a doubt the most complicated problem you saw tonight, but if you take it step by step, it really isn't too daunting. So I'm going to start the way I did my last problem by giving the power of 3 to everything inside the parentheses. So distributing, but not distributing. To give me 3 cubed, x to the 9th. Power to a power you multiply. 3 times 3 is 9. Y right here is really raised to the first power. 3 times 1 is y to the third over x to the 6th. Then I go to my second set of parentheses and I take the 2, the power of 2, and give the power to everything inside of the parentheses. So distribute, but not distribute. Everything needs to be squared. To give me y to the 4th, again, I'm multiplying my powers when I have a power to a power, x to the 8th, 5 squared, y squared. Okay, now that I have two fractions that have been simplified, I'm going to multiply straight across the numerator, straight across the denominator, just like I would with any fraction multiplication. So I start by looking at my numbers in the numerator. This is really 1. 3 cubed times 1 is 27. 3 times 3 times 3 is 27. Next, I'm going to look at my like bases of x. Whenever you multiply like bases, you add their exponents. So this becomes x to the 17th. 9 plus 8 is 17. I then look at my like bases of y. Y to the third times y to the 4th is y to the 7th. And that's all going to be over. Again, look at your number. 5 squared is the only number down here besides the 1 in front of x to the 6th. 1 times 5 squared is 25. X to the 6th is the only x in the denominators, so it's x to the 6th. And y squared is the only y term or y number in the denominator, so this stays y squared. From here, I now have a simplified quotient, so I'm going to use my quotient property to simplify these. You always want to start by looking at the numbers to see, is there a common factor that you can simplify? 27 and 25 don't have any common factors, so that's how that fraction is going to stay, 27 over 25. You then move to your next like bases, x to the 17th over x to the 6th. When dividing like bases, you subtract your exponents. So 17 minus 6 is x to the 11th. The last thing I'm going to simplify is y to the 7th over y squared. which is going to give me y to the 5th. Because again, when you divide like bases, you subtract their exponents. So my final answer is 27 over 25, x to the 11th, y to the 5th. All right, because you know how much I love math, I did number 44 just for fun. It might be a good idea if you found 45 difficult to go ahead and try number 44 and compare your final answer with mine. Again, I followed the same procedures that I did with 45. The only difference was right here. 4 over 400 simplifies to 1 over 100 because 4 and 400 have that common factor of 4. So I just reduced that fraction to be 1 over 100. So again, I'd really encourage you to just take a couple more minutes and try number 44 and see if you get the same answer that I did. I hope you have a great night, and I'll see y'all tomorrow.